Hi, and welcome to video 4 for section 1.6. This is the fourth of the 4 videos. And this problem, or in this video, the kind of problems we're going to be looking at are distance equals rate times time. So there's a funny YouTube video out there, a couple guys talking, and the one guy says, you know, if my car's going 60 miles an hour, how far can I go in 1 hour? And for whatever reason, these guys, maybe they're on a little something, I don't know, but they're not able to figure it out. That's what these kind of problems are. So if I'm going 30 miles an hour for 2 hours, 30 times 2 is 60 miles that I'll go. Distance equals rate times time. If that's where we ended, that would be nice, right? Unfortunately, that's not what these problems are now. We're usually going to have two trips that we're trying to compare either times or rates or distances, things like that, and we need to develop this relationship between the two pieces. So let's look at this example, and I'll kind of show you what I mean here, this relationship. So we have a salesman drives from Ajax to Barrington, a distance of 120 miles. He increases his speed, so it didn't tell us how fast he was going, but it now tells us that he increases his speed 10 miles an hour for the 150 miles from Barrington to Collins. You see, they make it nice, A, B, C, so that's what we'll do here in a minute. If the second leg, so they're calling leg 1 Ajax to Barrington, leg 2 Barrington to Collins. So if the second leg took 6 minutes longer, how fast was he driving from Ajax to Barrington? So I'm just going to call it A to B. Save ourselves some writing here in ink. So again, go ahead and hit pause if you need to catch up on the writing, and then we'll start working this. All right, so a bunch of stuff going on here, a bunch of variables we're going to have to contend with. But let's look at, again, like I told you, we have to figure out the relationship for this kind of problem, right? So how are the times related? Or how are the rates related? Or how is the distance related? Well, what does it give us here? And again, the last sentence is where you're usually going to want to look for this. If the second leg took 6 minutes longer than the first, how fast was he driving? So that means what? So it means that the time, so we have what? We have distance equals rate times time. And in this case, we have what? Well, we had Ajax. He drove to Barrington. Then he drove to Collins. So the distance from A to B, from Ajax, let's fill in what we know. Ajax to Barrington was what? It was 120 miles. How fast was he going? Well, that's what we're trying to figure out. So let's call that X. So this is distance. This is rate. So from Barrington to Collins, the distance is what? It's 150. Well, how fast was he going from Barrington to Collins? Well, we could call it y if we wanted to add another variable, but that's making it messy on us. What do we know? We know that his speed was 10 miles an hour more than the first leg. So if this was x, this would be what? X plus 10. If he was going 15 miles an hour faster, x plus 15. If he was going 10 miles an hour slower, x minus 10. So we can relate these two speeds together. What don't we know? Nothing in here is mentioned about time, right? But we know that what? We know the distance from A to B is equal to the rate from A to B, Ajax to Barrington, times the time from A to B. And similarly, the distance from B to C is equal to the rate BC times the time BC, Barrington to Collins. So this is the information we have, the formulas we know. Again, if we go back to the relationship, what do we know? We know that B to C took 6 minutes longer. So that's going to be the time for BC is bigger. So I know that the time from B to C minus the time from A to B is equal to what? Well, this is where we have to be careful. It's equal to 6, right? 6 minutes. But when we're dealing with word problems, especially distance, rate, time problems, we have to make sure that all of our variables or all of our information is in the same units. So what do we have here? 10 miles per hour. Not miles per minute, miles per hour. So we need to know 6 minutes is equal to how many hours? So 6 minutes equals how many hours? Well, we know what? We know that 1 hour is equal to 60 minutes. So again, whoops, let me change this up. So 6 minutes is what? How many hours? Well, we know that there's 60 minutes in 1 hour. So therefore, we know what? We know that 6 minutes is equal to 1/10 of an hour. So how do I want to do this here? Let's see. So we have 6 minutes. We want to know how many hours this is equal to. So 1 hour is equal to 60 minutes. So to convert this to hours, I need to multiply this by hours over minutes. That way my units will cancel out. So we know 1 hour is equal to 60 minutes, and then if I simplify, 6 cancels with 60 gives me 10, so I have 1 over 10, so 1/10 of an hour. So that's how I got 1/10. So we know that the time from Barrington to Collins minus the time from Ajax to Barrington is equal to 1/10 of an hour. Now I need, what are these guys? I don't have any information about time. Everything else was given to me, but I know what? I know that the time from BC is what? So if I have distance equals rate times time, if I divide both of these sides by r, that means what? Time is equal to distance divided by rate. Or similarly, rate is equal to distance divided by time. So if you want to put those three formulas on your cheat sheet so you have it, that relationship, you can. Well, I want TBC. Well, that's what? Distance over rate. So from B to C, I have the distance is 150 over the rate, x plus 10, minus the time from AB, which is what? Distance, 120, over x, and again, this all equals 1/10. So now that I have that, and that's why these problems can get a little bit messy, is I need to solve this equation, and to do that I have to multiply by the LCD, which in this case is going to be all three of these multiplied by each other. So 10 times x plus 10. That's my LCD. So I'm going to multiply this by every term, again, to get rid of the fractions, and then I can solve the equation that I end up with. So we're going to erase all this verbiage here. So if I do that, when I multiply 10 times x plus 10, the x plus 10's cancel, and I get 150 times 10 times x. And then minus. Now the x's cancel, so I get 120 times 10 times x plus 10 equals, now the 10's cancel, so I get x times x plus 10. So I have this big equation now. So if I do this, I have 150 times 10 is 1500 times x, so I got 1500x. Here I have a minus sign, so what do we have here? This is 1200, and then I have to distribute it to both of these pieces, so that's what? It's 1200x plus 12,000, 1200 times 10. And again, it's a minus sign here, so be careful. So minus 1200x minus 12,000. And then here, if I distribute this, what do I get? I get x squared, and then plus 10x. X squared plus 10x. So on the left side here, 1500x minus 1200x is 300x. Minus 12,000 equals x squared plus 10x. So I'm going to move everything over to the right so that my x squared stays positive. So I'm going to subtract 300x, and I'm going to add 12,000. So that gives me what? 0 is equal to x squared minus 290x plus 12,000. And so this goes back to our factoring and solving equations, right? So can we factor this one? Hopefully, or likely, your problems will be a little bit easier than these numbers. You could use quadratic formula if you want. But if we try to factor this, this is actually going to give us x minus 50 and x minus 240. So use zero property rule. X minus 50 is equal to 0. X minus 240 is equal to 0. So that says x is 50 or x is 240. So now, this is, once we get an answer, then we have to ask ourselves, especially with these word problems, which answer makes sense to what's being asked. Well, this question said what? We're trying to find out how fast was he driving. Well, does 240 make any sense? Maybe for some of you, not for me. I'm beyond my days of even trying to do 240. Unless you got an Indy car, you're probably not going anyways. But so 240 doesn't really make sense in this situation, right? So we're going to not count that one. If you had that as an answer, I wouldn't mark it entirely wrong, but at least on the first exam, I'd probably say to you, does this answer make sense? Because our answer is what? How fast was he driving from Alex to Barrington? Right, that's what I said, yeah. Or from, Ajax to Barrington. So the answer would be 50 miles an hour. So you can see These problems can get pretty messy. These will probably be the ones we'll spend the most time with in class, just from historical questions that people had asked me. Again, the other ones, you have a table, you have the equation, the proportion ones, you know what the steps are. This one's a little bit more messy because of having to figure out what is this relation. And then once I have this relation, then I can build the equation. But until that, it can get a little bit dicey. So give these guys a try. Whatever you can't get, no problem. That's why we do the flipped class. You can come in, you can ask about those questions. But that's it. That wraps up the videos for section 1.6. Come on back and we'll look at section 1.7.